Yeah, so I'm Adam. Hi everyone. So I'm a full stack developer, but I definitely come from like a web developer background. But I want to convince you today that like desktop apps are worthwhile, and that if you are a web developer, you basically already have all the skills that you'd need to be a desktop app developer. So yeah, I'm ahead of Teamwork Chat at Teamwork. So we have web, mobile apps, and 2 NW.js apps. You might already know me from like this stupid joke, Corkonian scripting language KED that I went around a few years ago, or I helped maintain a few NW.js related projects. And I recently wrote a book on Electron. So, and there's my details. My slides are on my GitHub anyway. So, NW.js. So, I don't have a lot of time to like cover the history and stuff. So, like, let's just go back to like 2011. So, 2 guys, Roger Wang and Sheng Zhao from Intel, started Node WebKit. And as the name suggests, that's Node and Chromium together as an app runtime for the desktop. But has recently been renamed to NW.js because at the time it wasn't Node anymore. It was using autoUpdater, the Node fork, and it was using the Chromium after moving on from WebKit to Blink. So since it was Chromium and Node together, it's basically Chrome on the desktop plus your app code plus Node. So you got to write UIs in HTML, CSS, and JavaScript, which is great. And then you also had Node, all the Node APIs, so you could like read, write to disk, you could like execute system commands, you could spawn out executables, you could do all different stuff. So it's like a really powerful combination. But like how does it actually work is like this is Chromium, and there's like a main backend browser process. You might have noticed it like in your task manager or whatever, that there's 2 processes. So there's one process for the main background process, which has, this is where like, say the renderer, the JavaScript engine, platform APIs, which abstract native APIs, all that lives there. I don't really know enough about it to actually lay out the components. That's for people way more intelligent than me. So each tab actually has its own process as well. They've done this for like fault tolerance. So each tab is an isolated process, and it has access, to the CSS parser and the DOM and stuff like that. But the main process and each tab will actually communicate through inter-process communication, or IPC for short. So how NW.js took this is that there's a main browser process. Each window is its own isolated process, but they basically maintained a patched version of Chrome where they like patched in their own hooks so that they could access Node.js. So yeah, like I said, that allows you to do a lot of different stuff. You can like require different scripts, and I'll show you a bit more in a second. So this is basically the hello world. So since your app is basically Chromium plus your app code plus Node, it's basically just a web app in Chrome. So all you need is a HTML file and a package.json. And if you're not used to Node, then package.json is just a manifest that has the name of your app, the version, the main file. It's just a property that points to the main entry script. And in Node, that's usually JavaScript, obviously. But with this, it's a HTML file, because with an NW.js app, the main entry point is a window, which is a HTML file. So by default, your app has one window, and from there you can open other windows. So basically, what you need is a package.json, and the npm init command here, it will generate a default one for you. And all you have to do is replace index.js with index.html, just because you need to have HTML as your main file. And then once you install the official NW package, you just run it in the same directory, and you get an app. So that's not very pretty, but it's pretty powerful, because you've all the tools at your disposal already to style this in any way you want. So you can have like, this is obviously very, very basic, but like you can have custom frames, you can have frameless windows, you can have transparent windows, hidden windows. And I kind of took this a little bit further and like made Clippy with NW.js. So I got kind of a kick out of doing this, like putting Clippy on Mac and on Windows 10. But if you follow that link, there's the code and a blog post explaining how I done it. So on top of actually all these Node APIs and browser APIs, HTML, CSS, JavaScript, you can have access to all of NPM thanks to Node. So I see NPM has passed 300,000 modules. There's a lot of great stuff on there. You have access to all of them. So say, for example, at Teamwork, we created an auto launch module, it's called. And basically what it's for is it allows you to set your NW.js or Electron app to boot when the machine starts up. So you might recognize this. This is Atom. So this is GitHub's text editor. But whether you use it or not, this is actually like a massive game changer for desktop apps. So it started out as Atom, but so what happened was GitHub took Sheng Zhao, one of the main maintainers of NW.js, over to GitHub, started working on their own text editor, and open sourced. They basically forked Node WebKit as its base and called it Atom Shell. They later open sourced that, improved on the formula, renamed it to Electron eventually. It's kind of a clever name. But they, so since then it has hit like version 1.0, has gone from strength to strength. It's more popular than anything, especially with GitHub pushing it. So there's a lot of actually real world desktop apps made with like Hyperterm, and like you can manage your Docker containers. Like Nihilist here is a great one as well, where it's a mail app and they're really pushing it with performance on the desktop. It really, really feels native. So how is it actually different? Like, why is Electron taking off more than NW.js? So one is like how they've tapped into Chromium is a bit different. So NW.js basically had to maintain this patched version of Chromium. So for every release, they had to look over the code again, patch back in their hooks. So what Electron done is like they actually like basically made pull requests so that they can run multiple runtimes, JavaScript runtimes at the same time. So they can have Node.js in the main backend process as well as in each window or renderer process. So what that means is, unlike NW.js where a HTML file is your entry point, you have one window by default. With this, you have no windows by default, and your main entry is a script. So from there, you basically open any windows you want. I'll show you an example. So this is like the main script. It's very simple. All it does is once the app is ready, it opens a window, loads a local file. Okay. So like the app, all the window management is here. So like there's a few built-in modules that come with NW.js or Electron, and in Electron's case, what they do is a lot of them are exclusive that you have to use them either on the main side or on the renderer side. So like all window management needs to be done on the main side, and like say auto updating and things like that. But I'll get to that in a minute. Whereas with NW.js, you can kind of do whatever you want from in a window. So yeah, there's your main script again. So the hello world for Electron is create a package.json. This time it can point to index.js, that would be your main file, this one. And install Electron pre-built and run it, and then you basically get the same app. So like, what's the big deal? Like, this looks the exact same, right? So all that's different so far that I've said is like that there's distinct processes with Electron. And okay, that's a bit cleaner, but like, you know, it's not a massive deal. Why is it like taking off so much? So one is like mindshare, like just because it's taken off, more people notice. There's a big community behind it. There's a lot of tools. There's a lot of projects, little things that help you get along. So there's really good support as well for it. Like the documentation is really good. They are really on top of like GitHub issues and stuff. It feels a bit more stable, definitely. Like where if you create an issue, you could see a reply within a couple of days. Whereas with NW.js, I've seen 3-year-old bugs, confirmed bugs that are still there. But like, I don't really hold against them. It's really tough because like it's an open source project where it's written in a language that's like alien to the people who use it. So you don't really get many contributors. Like, you know, it's like C++ and stuff. So I wouldn't be going near it. So as well as that, Electron basically, so when they forked from Node WebKit, they improved a lot of the APIs. Like there's a lot of little things in NW.js that doesn't make sense. So like, for example, there's an API to bind global shortcuts. So you could bind like Control A, and that will fire no matter, even if your app isn't focused anywhere on the machine. But intentionally, it's weird. It's intentionally, and it's confirmed, but you can't actually bind to the Control key on a Mac. It actually maps to command. And if you bind to command, it maps to command, and it's a bug that's been open for ages. It's confirmed, like, and it makes absolutely no sense. And there's other things about that API that doesn't make any sense in other APIs. And basically Electron, when they forked it just made all that stuff make sense. Just straight away. So it seems to be maintained a lot better. They also added new APIs, like the autoUpdater module. NW.js doesn't have a built-in autoUpdater module. Also, I said their documentation is really good. They actually have like an app that shows off their APIs, shows you how to write the code and actually execute it, which is brilliant. So, for example, the typical stuff like say that NW.js already had was like, you can open a URL in the default browser, you can show a tray icon, or you can like trigger a notification, a native notification, things like that. For example, like this is an NW.js app. So if I use the HTML5 notification API, I get a notification. It's that easy, right? But like, so there were a lot of APIs already existing. But these Electron added a lot more, like autoUpdater and stuff, and they added a lot more desktop integrations to really integrate in desktop environment. But this API demos app is actually really, really good because, like for example here, this is a demo how to have basically like you ever see like iTunes or Spotify, you click a link and it tries to open the app. You can have that as well with Electron. So here's a demo to bring you to a page which has a link, and you can launch and come back to the app, and it knows it came back. So it's like that's taking documentation to the next level, really, I think. So, but is it really native? Does it really feel native? I don't think there's much of a difference. Like, it basically, like, how many desktop apps can you think of that really look like Finder and Windows Explorer? They all look a bit custom anyway, don't they? So, like, and plus, like, there is a difference between, say, native desktop apps and a web. For example, if you hover over a button in the web, the mouse will turn to a little hand. And on a desktop, a native desktop app, that won't happen. It just stays as the default cursor. But like, is that really better? Like, so is there a reason to be fighting these like little better experiences with because it is actually a web browser? I'm not really sure. So, but if you really wanted to make it look like it, there are actually like modules out there to help you. So like there's Photon, for example. That's all CSS. So it's basically like Bootstrap for OS X components. So if you really wanted that look. But is it like slow or laggy? Right? Not really. Like it's basically a web app in Chrome. That's how it performs. If you're a web developer, you already have the tools to debug and to monitor all that performance. Like the great thing about it being based on Chromium is that it already has access to the dev tools. So you have the timeline tab, you have all that. So that's great. But one interesting thing about Electron is that, or NW.js, is that you can actually squeeze more performance over it. Like, what you can do is like, well, for example, because it's based on Node, Node has support for native modules, which means you can write modules in C++ or C. I don't know that much about it, but if you really, really want to go really low level, you could. But there's never really need for that much. But say there's other things you could do where like you can execute, you can spawn other executables and stuff to do some work there. Or what you can do is you can create a hidden window, and you can do a lot of the work, the processing over in that window, so it doesn't affect the rendering and painting in the window you're in. So you basically would have to Electron allows you to communicate between the main and the render process through an IPC module. So you can basically like emit events, any arbitrary events, just like say like Node's event emitter, if you know it. You can emit events on one side and just catch them on the other and handle them. So what you would do is you would actually, if you needed to do some work, you would emit event over to the main side then would emit event over to this hidden worker window, and then you would do all the work, give the result back to the main window will proxy it back to the actual view. So if you actually wanted to go ahead then and share your app, if you actually made something good, there's a lot of platform support that actually like, so you've Windows, Mac, and Linux, and you can go 32-bit, 64-bit. So you don't really need 32-bit or 32-bit Mac or Windows, but say for Linux you need both just for compatibility. On top of that, NW.js is really hard to get into the Mac App Store. You have to really jump through a lot of hoops. Whereas Electron actually has Mac App Store compatible builds. So what it does is, it's basically a normal build, except a couple of their modules are ripped out that wouldn't get through the app review process. So for example, like the autoUpdater process. But that's not a big deal because you're in the Mac App Store, so you're getting Mac App Store updates, so it's grand. Electron supports ARM, so you can like build for Chromebook, Raspberry Pi, and on the other hand, NW.js supports building for Chrome package apps. So if you are, so Electron is basically has one, it's a turning point. But like, so if you were to build with Electron, there's Electron Packager, which is just basically for packing your app up into like a .app or .exe, and that's it really. It's great, it's nice and everything. And there's loads of other modules like this, interactive ones and all different stuff. But Electron takes this module and actually builds on top of it with other modules for generating like DMGs and Windows installers and all different sorts of stuff. That's a really good one to check out. It also handles code signing for you, which is really important because like you don't want to trigger like the Windows Smart Screen when the user tries to open your app, or you don't want to like trigger like antivirus software and things like that. But the annoying thing about code signing is if you didn't have to code sign, you could build any Electron app on any platform, but because you have to code sign, you have to sign it on Windows for Windows and on Mac for Mac. So the great thing about Electron Builder is like it does all this code signing stuff for you, and it is geared towards like automation. So it's like it was made with continuous integration servers and services in mind. So you could just have it run on a click of a button or basically on like a push to GitHub or whatever. So you take a lot of this work away because it's a bit manual having to like, if you have to release your app, you have to go on a Mac and go on a Windows and build it and sign it and stuff. So automatic updates. So NW.js doesn't have automatic updates, but it's Node, so you can do whatever you want really. There's third-party modules there for it that essentially replace the app with the new version and stuff. But on Electron, they have an auto-updater module built in. But it doesn't support Linux, first of all, so you have to just publish the package managers. It's not a big deal. But so it supports Mac and Windows, and it's a really simple API. All it is like once you give it a URL, then you have another method where you can check for an update. It's event-driven, so like you can just listen for events like update downloaded, and once that update download event is fired, you can call the restart and install event method, and it'll just restart the app and update. It's really simple, so there's only 3 methods. But it's not as simple under the hood really because it's based on the Squirrel framework, which is actually drastically different for Mac and Windows. So Mac under the hood, under the client, is really simple. But you need a server. So what happens is you give it a URL, and when you say check for updates, it hits your server. What your server has to do is return a 204 if there isn't an update, and if there is an update, it has to return a 200, which with a JSON response with a URL pointing to a zip. So then under the hood, Squirrel.Mac would know what to do, go get that zip and all that. So that's done for you. So under the hood of a Windows Electron app, there's actually a lot more code, and you don't need a server. You can use a server, but you don't need one. You could host static files somewhere, like on S3. You could even have them on the machine itself, which is actually really handy for testing. So you can kind of find a happy medium where you have a server for both, and you can store them on S3 and stuff. That's probably like the optimal way to do it. There are a couple of advantages to Squirrel for Windows though. They apply their updates in the background, so when you do like a restart and install, the actual update's already done. It just needs to kind of, I won't get into it, but it kind of has to, it's just a lot quicker anyway. It also supports Delta updates. So what that is like when it goes to check for updates, if you're only say like one version behind, it'll download a binary diff of between the version you're on and the new version, and just apply that to your executable. So it can even do that like incrementally, like patch it if you're like 3 versions away, but it'll only do that if it's worth it. Otherwise, it'll just download the whole, if you're 15 versions behind, it'll just download the whole file or the whole zip and just like overwrite it. But the great thing is that that's all just done under the hood for you. The API is still really, really simple. So you just check for updates. It does the stealth update stuff. It does all that stuff, and then it just gives you an update. And so it just tries to do the optimal way to make it faster. So that's great. And as I said, like the server is really simple anyway, right? But they're actually, like the great thing about Electron is the community behind it and all the different projects and tools out there that you can just build on top of. So like there's already projects out there that just are the servers you need. Like so there's one like Electron release server. There's different ones with say, you just run it basically, and like some of them have even admin dashboards where you can manage the updates, and there's ones that like have support S3 as a back where you host all the files, or other ones support like GitHub releases if you want to do it that way. There's all different stuff. It's great really, the tooling around Electron. So what's it like making a desktop app versus a web app? Well, browser lock-in is a great thing, but it's kind of like a guilty pleasure. Like if you're only making a desktop app, then you know exactly what version of Chromium all your users are on. So let your imagination run wild, like you Flexbox, pure WebSockets, like WebRTC, anything you want. You can do anything. On top of the fact that you have access to all of Node APIs and NPM. So it's great that you know exactly what's going on. You'll never have to deal with an IE bug. Like. So another interesting thing is that it's basically offline first because you're dealing with local files. You can load remote URLs, but it's usually not done. So like you usually load local files, so you have to have the mindset that your app is going to run even without a connection, and you need to handle that. And yeah, you might queue events for when the connection comes back and things like that. It's just kind of a different mindset. Speaking of local files, dealing with the file protocol, like say for example, protocol-less URLs, you can't use them anymore. So what I mean is like where a URL starts with 2 slashes and it just expands to HTTP or HTTPS, it'll expand to file and that'll break. So like you'll have third-party modules that will try and load something from, I don't know, whatever, and it'll just break. So you've got to be careful of that. Some other interesting things like, I don't know, like you'd never use a CDN because like local files are way quicker. There's no, like in a browser you'd worry about like the maximum, there's like a limit on the concurrent request for assets per domain. That's gone when you file URLs. You can just load as many as you want in parallel, go wild. So another thing that's kind of annoying is like, there is a lot of work. There is a lot of like asset generation and stuff. So like, if you didn't want to have an app that like auto-updated, when you first release the app, you have to like build the app, create installers, create a DMG, figure out like your auto-update system. You have to, then on every update, you have to build another installer, another app, because if someone goes to the app to download the newest version. But also, for the Delta updates, you actually have to generate those binary diffs as well. Luckily, though, that Electron Builder module still does all that. So it's like, out of the box, Electron Builder is made for like handling everything for you and even integrating with like continuous integration servers and doing all the Delta update stuff here. It's really good. There's some like unexpected behaviors though. There's kind of some obvious stuff, but they're still really annoying. Like for example, if you have like a small window and you have a select in it. So I don't know, let's say you just have some like little Electron app that's like a music player and has like a mini thing and there's a select. That select will like go outside the bounds of the app, no problem and all that. But the second you use like a non-native select library, like select2 or chosen or anything like that, it's obvious like, but it gets cut off by the browser. So it's like you see a couple items and it's cut off, and that's really frustrating. Like, don't get me started on select so bad there. Other stuff like, you might realize, but like on Mac, every window has like a header and a body, right? And when the window isn't focused, you can hover on the header and the hover styles apply. So like, just think of it like the gray, maximize, minimize, close. You can hover on those and click them. But you can't actually hover. When you hover over the body, it actually doesn't apply the hover styles. And this is actually like a thing that's intentional, right? So when you think about it, your app now is Chromium, but missing the header, and your whole app is basically your web page. So that's the whole body of the window. So like when you could like drop the native frame, but like and put in your own custom buttons for minimize, maximize, close. But if your window isn't focused and you hover, it doesn't react. It's really, really strange looking. It just feels really wrong. And when you click, the first click will focus the window, and the second click will actually click the button and close the app, which is like really frustrating. To make it worse, there's actually a bug in Chromium that if you move your mouse at a certain speed, it does do that. It does work as you might have expected, but it's a bug because it doesn't meet the platform expectations. So what they want to do is fix it so it doesn't do hover when you move quickly, but it can trick you into thinking that it did work, but then half your users are actually frustrated that they know it's not a native app and it's just driving them crazy. You don't even know because you just move your mouse a little bit faster. Tooling and stuff, well, you can use pretty much all the same stuff because like it's just HTML, CSS, JavaScript, right? So you see there's loads of like plugins that plug into Gulp and all different stuff for like even signing the apps if you didn't want to use Electron Builder and stuff. So let's say stuff like if you want to like watch files and stuff, that's a bit trickier because you compile your assets and you actually launch the app. But there is a module called Electron Connect that like will actually reload your renderer and reopen whole app if you edit the main.js. So it's not bad. But like it is Node, you can technically do anything you want. So like you could run Webpack inside your app if you wanted. I have no idea why you would, but I'm just saying the options are endless. But what's it like to actually like maintain and live with a desktop app? Well, like first of all, the release flow is really weird. Like there's like a different mindset with releases. So like when you're working on the web and you break something, it's not really such a big deal, like depending on your app. But you can just roll out a fix and then users just trickle in and it just works again. Or like bad web developers might like say, build out a feature for a deadline and it could be like 80% there and they're like, oh, it's grand, we'll fix the bugs that come in tomorrow that are reported or whatever. You can't do that. Like you can't really take back updates that you put out. It's more like a mobile app kind of flow. So you build your app, you put it out there, you can't take it back. Users might not even update from that buggy version to the next buggy version. So you're just constantly worried about all these bugs you have in all old versions. So like, as well as that, like because you've all these old versions, like your code could exist in different forms, like in different states. So like you could have 10 different variants of your client hitting your API in a slightly different way. So you have to worry all about these things like versioning your API and having it really, really locked down and tested. And let's say like if you're attempting not to increase the version on the API, you're not sure if it's a break and change or not. You're worried if you're going to break a desktop client that was released a month ago because it has something slightly different. So like the problem with that as well is that like when it does break, it's pretty fatal. So because like all the auto updating stuff is done in the app, you can have a fatal error that crashes your app before it even gets to the stage where it checks for an update. So like your user could open the app, update downloading, crash, open the app, update downloading, crash. So you have to basically reach out to all your users and have them all reinstall the app. So trust me, I know, it's terrible. You get really strange bug reports and like unexpected problems. So like, I don't know if you know, but like there's a 256 character limit on file paths on Windows. So like these are weird problems that you don't have to deal with when you're a web developer. But like, so if you use an npm before version 3, node modules have a node modules directory in it, and its dependencies has its own node modules and it keeps going. So you get this like across a like really long path. So we had a problem where like paths went over a certain length and the app would just not launch or else crash just after launching. So that's a major headache. So like what we do is we made a module so that like in our continuous integration, we simulate as if every path in our app is placed in a user's app data on Windows who has a long username and check if any of those are over 256 characters. You can also get around this by like you should probably do that anyway to be safe, but like if you use npm 3 or later, they like try and flatten the dependency tree. So it helps a lot. But you know, there's other reasons why you could have long paths. We get really, really strange bug reports. Like, I don't know, like I have an issue with like an admin in a Mac hot desk situation, and it's like there's loads of really weird edge cases that you wouldn't have to think about, like this antivirus in combination with this, or like say a Windows user might have messed up their environment variables and one of your node dependencies might try and use a built-in system command and it doesn't exist and your app just dies. Just loads of strange problems like that. So like you want to like track everything properly, but the problem is like, even if you want to use Google Analytics, it doesn't support file URLs out of the box. A lot of them don't, so they're kind of gone, just kind of workarounds. But like bug reporting, you really want to like lock it down by version as well. Whatever tool you're using, you really need to have support for like versioning. So like, because you could fix a bug and it could still be filling up your logs because you're after releasing it, but there's still people out there using last week's build or whatever, you know. It's pretty frustrating. And it's also like filling up your quota, so you probably want to like recycle your API tokens for whatever tool you're using after a while as well. Automated testing. So say for example with NW.js, there's not much you can do. It is Node, so you can kind of do whatever you want. There's a way to kind of get in and test the app, but it's pretty tricky. I mean client side, like high level, kind of like Selenium test. They do support Chrome driver with NW.js. I haven't used it myself, but yeah. But with Electron, there is actually a Spectron where you can actually like simulate all the events as if like you click the maximize button and check if your app reacts accordingly and stuff, so you can actually properly test it. And besides that, you can kind of do whatever testing you want in the app anyway, because it is just HTML, CSS, and JavaScript anyway. Yeah. So, but like it's not necessarily just desktop or web. So as a web developer, you have all the tools to be a web developer and a desktop app developer now. So why not kill two birds with one stone? So what you need is like one, you're using, well, forget about all this browser locking stuff. Stop using like native WebSockets and WebRTC and stuff because that won't work in all the browsers. But say you have now, you're using node style requires everywhere to require scripts and node modules and stuff like that. So one, don't require any node stuff because it just won't work. Two, use a module bundler like Browserify, which will like go over all the CommonJS style requires and like traverse all your files and pull it all into one script compatible for the web. So when you're developing it'll feel the exact same, but it's actually just one script. But then you could end up with a lot of redundant code in the web, for example. So like you could require some script that does like massive desktop integrations, and but you won't need it. But it is bundled into the web. But it mightn't go into pass an if that checks if it's in the desktop or if it's on the web or whatever. But it's still there. You're still loading it. So there is a way around that. For example, with Browserify, there's like a plugin or transform called Envify, and instead of like detecting whether you're in the web or in the desktop app or runtime, you could set it at build time and pass it in as an environment variable to Envify. So then you could use these environment variables in your code. So instead of saying like if detect if it's in desktop app, you could say if env dot is in desktop app or something like that. And what Envify do will actually like convert that to just like true or false or whatever the actual environment variable is. And then Browserify, when it actually does this static analysis and it's like traversing everything, it sees that and it's like if false, no, I'm not going to bother going in there. So then it doesn't even bother pulling in that script that it's requiring inside. Another problem is just that whole release mindset. It's like you're working on the web, you want to roll out quickly. So like I definitely believe in like continuous delivery. So like you want to be like ideally if you have enough testing, an intern could make a little tweak and it's just like runs through all your testing and gets pushed out live, and it's like small incremental change so it can be rolled back really quickly. It's great, but like you can't really do that with desktop apps. Like so there's kind of like a happy medium, I suppose, would be like maybe like rolling out the web often with like patches and stuff, and then maybe once a week or something making desktop apps. But then again, it depends on how you build the desktop apps. If you don't use like Electron Builder on like continuous integration services, then you might be doing a bit more manual work. So it's a bit too much to be doing that like too often. So there's kind of like a conflict there. But thankfully, because Electron's like automated testing module, Spectron, you could actually kind of roll it out as well on every push. But I haven't heard of anyone doing it yet. But yeah, so that's pretty much everything. That's my book. If anyone wants to buy it, there's like 50% off there. So I cover all this stuff in a lot more detail as well. Yeah, so that's it. So I just want to ultimately convince you that if you're a web developer, you already have the skills that you need for a desktop app. And if anything, your skills can be leveraged even more on the desktop. It's best platform for your skills because not only do you have browser APIs, you have node APIs for read, write, disk. You could create a game that like a roulette game that deletes users' files. You could use npm modules. You could write in C++ and C. You can do anything you want. There's kind of no limit really. So yeah, that's it. Thanks.
Take a quick 2 or 3 minutes for any questions.
Yeah. Hey Adam. So, like, I have to convince my boss that to use Electron. So one of the things on the checklist that he will ask me is like the out-of-the-box storage. Like, for example, all the limits that the browser puts on the local storage, on IndexedDB and Web SQL. Are those, for example, applied in Electron?
Yeah, but local storage is kind of like where this like exists somewhere on disk and it's accessible. It's really strange. But you can kind of do any storage you want really. Like you can use local storage. You could cache to disk. You could directly connect to some database if you wanted. I wouldn't recommend it, but you can do just like modules like NEDB node, embedded database. There's all different stuff that you could use for storage. You could. It's kind of related, but like you could use Service Worker because like you know exactly everyone's on Chromium and stuff, you know.
Mm-hmm. And the other one is like one of the reasons to build standalone apps is to access like cameras, web cameras,
Yeah.
microphones, and so on. But let's imagine that is a custom hardware for a specific company. Like, so we need to write some C++ using drivers and what so on. Like,
Yeah.
Would that be a problem?
No, it's completely possible. Like I said, I don't know much about it, but with Node you can build native modules in C++ or C. If you want to dip that low, you have to kind of like pre-build it for target platforms. You probably have to build it for different ones, and there's problems with that. As a Windows user, I run into some issues like that when I use native module dependencies, but it is possible, definitely. But like, say, if it wasn't custom hardware, you know, you can tap into all sorts of stuff like that, because like you can use HTML5 MIDI API, all different experimental stuff. You can turn on custom, like hidden stuff in Chrome that is like experimental and stuff, through the flags. So there's a lot you can do, really.
Okay, thanks very much, Adam.
No matter.